Hey, g'day, it's Prezzo. Thanks for stopping by. Now, I'm starting a new project today, so let's have a look at what's on the bench. So here's some materials we're going to be using in the project. We've got some brass angle stock. We've got some brass strip stock. This is being cut to various different lengths. We've got some sheet metal brass parts that have been roughly cut to size. Got some 3D printed parts. And we got some 10mm borosilicate glass tubing. So I guess you're wondering, what am I going to make out of all this stuff? And the answer is a steampunk inspired set of pan pipes. And the answer is an Art Deco inspired wall sconce, or actually two of them. Now you're also probably wondering, what is a wall sconce? Well, here's a picture of one. So a wall sconce is a light fitting that you screw to the wall. This is a very old style of light fitting. These were used back in the times when we had candles and oil lamps as our only source of lighting. And the reason they were attached to the wall is that it was easy to get at. So they could be placed about head height, and you could usually get at the inside of that wall sconce and you could light a candle or clean it. You could fill it with oil. And another reason why these were attached to the wall is that they could be actually projected away from the wall so that heat and flame would have a harder time actually setting fire to wallpaper or curtains and so on. Now when these light fittings were electrified and they fitted light bulbs to them, they served the same purpose. And a wall sconce is also very handy when you have very low ceilings or very high ceilings. So if you got low ceilings, you can place it against the wall and there's less likelihood that somebody's going to bump their head on it as they walk past if you had it fitted to the ceiling of the room or the hallway. And when you have very high ceilings, you can place the light at a level where it's going to do more good. So these things are often used in, say, hallways in hotels, in cinemas, where you would have these very, very high ceilings that are placed along the wall of the cinema, and that would illuminate pathways and walkways down the side of the cinema seating. Now, this is Art Deco inspired, and this is going in a room in our house because our house was built, well, it's actually a replica of a house that was built in the 1920s, and that was leading into the period when Art Deco was at its height. So the wall fittings that we have in this room at the moment are sort of Victorian style. They're not old lights, they're new replicas, and the trouble is that they're very badly made, and what happens these days is they make them out of steel and they chrome plate them or plate them in some way, but they don't do a very good job, so corrosion starts to come through from the underside of the plating. So we want to replace them, but we want to use something which is going to last a long time. So that's why we're going to be using brass, because it doesn't corrode as readily as steel. I'm going to electroplate the brass when I'm done, and we're going to use glass because unlike plastic, it's very heat resistant. It's not going to crack or break down over time. So that's the project. So we're going to get started. I'm going to make up a rectangular frame for the back of this light fitting. So you can sort of see here, there's a frame running around the entire back side of this, and that's what gets screwed to the wall. And then we're going to have some parts which are fabricated from brass sheet and brass strip. These are going to be castings and made of brass, and these will be electroplated along with everything else. So, fun build, and yeah, let's get started. This is a drawing of the rectangular frame we need to make. It's made of 3/8 wide brass angle, and it's 1/16 an inch thick on each leg of the angle. And all we're going to do here is to mitre one end of this stock, and I'll do that on the sanding belt. Then we'll measure out the correct length, cut it square, and then mitre the other end back to the line. So I'll go and get one end prepped now. Just got this little fence set up here. It's screwed down 45 degrees to the face of the belt, so I can work the stock in against the belt like that. And when I go to the opposite end, we're going to have to stand it upright like that, but you get enough feel against that fence there, you know you've got it square. So I'm going to do one end of each piece of stock. I've got several pieces, so I'll get all of those done now. Not these short ones, I've got one of these little vernier marking gauges, so I've set this to 83.9 and we're just going to scribe that off there. And on the longer ones, we're going to have to just use a steel rule. So these are 257, roughly there. So I'm just going to cut this square and then we'll mite it back to that line. Okay, I'll leave us 2 pieces for our frame. I've got to do 2 frames altogether, so there's going to be 8 pieces, 8 corners, but I'll just do 1 to give you an idea, and then I'll go ahead and make the rest off camera. So this time for the other end, I've got to put the piece in like that with the flat leg on top. I can see the scribe mark from where I'm standing here, and we're just going to keep cutting in until we just kiss that mark on this edge here. Okay, this is a fixture that I made up for doing the corner joints, so we're going to silver solder those miters, and it's really important that you keep this brass stock flat and aligned while you're heating it and putting the solder in the joint. So what I can do is lock these parts down just with those socket head cap screws, and you can maneuver these parts into position just by having those screws just slightly loose. So there it is there, and this cutout on the corner here is just so that we can get the heat into the brass and not take the heat out through this steel fixture. If that cutout wasn't there, we'd have to preheat the steel, which is a lot thicker, and by the time we got everything hot, this brass would most likely have oxidized and you wouldn't get as clean a joint. And what I can do later on is I can put the other part on this side of the jig here, or the fixture, and just move it over slightly and get at that corner as well. So we'll do the corners one at a time. So let's go and do that now. Just while I'm here at the bench, I thought I'd show you this. This was sent to me by James Long at Boring Research. Now, I bought a spindle square for my Bridgeport mill from James. Excellent tool, and he stayed in touch. He's sort of a subscriber to my channel, and he likes to keep in touch with what I'm doing here. And he sent me this just as a gift. And it's a little magnetic pickup tool, and it's brilliant. It fits in my apron pocket, and it's excellent for picking up tiny parts out of those little trays. You know, I got arthritic fingers. It's really hard to get my fingers in those little tiny compartments, get out screws and washers and so on. So you can pick them up with this, and then when you get them out, you just pull the plunger out and the parts just fall off the end here. Now, if you put it in your pocket of your apron, it picks up stray chips and everything, but they just fall off when you pull it out. So I'll just show you. Just got some rubbish off the drill press there, and obviously you wouldn't have those big pieces in your pockets, but you do get those little tiny chips, and if they're a nuisance, you just do that and they just fall off and it goes back in your pocket. That's brilliant, and you know, I really must thank James. I don't ask for gifts on this channel, but James did send me this, and I do appreciate it. So we're just going to coat this with some silver solder flux on the inside. It's probably better to use too much than not enough when you're doing this. And I'm just going to cut off a small piece of silver solder and put that in the joint or along the joint. Alrighty. So I'm using oxypropane to do this. So just gentle heat to start with. If you boil that flux off too rapidly, it'll shift the silver solder around. And what you should see happening is the silver solder should dry out, or at least the flux should dry out. And then it sort of goes glassy. I think that's run all the way along there. I'll just give it a bit more. Alright, that's one done. Now it looks pretty horrible, and we will need to pickle that to get rid of that silver solder flux. It's basically a borax material, and it will dissolve in sulfuric acid. That'll clean the joint as well. But I'll get all 4 joints done, and then we'll clean it all up at the end. Now there's the first frame done, and I just cleaned up this corner here on a Scotch-Brite wheel. It's sort of come out pretty good. It will need to be pickled in sulfuric acid though to get rid of all of this glassy flux on the inside of the joints there. And I don't know if you noticed, but I completely botched this corner here. I overheated it and it's melted away. So I'm going to have to clean that and then build that up with probably soft solder. And one of the good things about electroplating this material is that you can electroplate over soft solder, silver solder, brass, and it's all going to come out the same when you're done. But yeah, I just overdid it with the heat. What I'm finding with this silver solder that I bought is that it doesn't flow as readily as the stuff that I used to use. So back in the bad old days, you used to be able to buy SBA 45, which was silver brazing alloy, 45% silver, but they also put antimony in the alloy. And what the antimony did was it made it flow so much better. It just wets the joint, flows right through the joint very easily. Only problem is antimony is toxic, and if you boil the silver solder, the antimony comes off as a vapor, and it can give you the same symptoms as heart attack. And I've noticed that in the Model Engineer magazine, they reported a lot of model engineers in England dying of what looked like heart attack symptoms. But what was happening is they were doing this in winter in a small enclosed workshop, and they were breathing the fumes, and yeah, it was killing people. So what they've done is they, workplace health and safety, they removed the antimony, but it just doesn't flow as readily as it used to. Anyway, I've got another frame to do, and I can guarantee when I get to the 8th corner, I'll have it nailed. All right, this is the 8th joint, so let's see if I have nailed it. So what I found is that heating it from the top works better. It's a lot easier to judge the temperature. If I push it into the corner of the bricks there, I can get some reflected heat back from the fire bricks. And then I put the silver solder in when the brass has gone red hot. And it just sort of flows straight away. So a bit counterintuitive, it's not how I thought it should be done. It just shows you if you stick at something long enough, you'll work out the correct method. And you may not have noticed there, but it just sort of ran up that vertical joint, filled the mitre, and I don't have as big a build-up of silver solder in that corner there. So everything I showed you in that first example, just ignore that. That's the right way to do it. Alright, so there's the second frame. Here's the first one. And they're nice and square, same size. So what I'll need to do now is just clean up all these corners, get them all sort of semi-polished. Right at the end of this build, we're going to have to do all of the polishing on the brass and get it really, really good before it goes into the electroplating bath. Now that these silver solder joints are done, we need to remove all of the excess flux. They're still on the surface of that brass there, and it sort of goes like a glassy consistency. Quite difficult to remove any other way, but an acid pickle will eat through that flux very quickly. It will also remove all of the oxide from the brass. So I'm going to do one of these in sulfuric acid, and then I'll show you a safe alternative to sulfuric acid if you can't get it. So let's get this one in the acid first. Okay, what I've got in here is about 15 litres of dilute sulfuric acid, and that green colouring, or the blue colouring you can see there, is just contamination from copper. So I've used this quite a few times for pickling copper. Some of that copper goes into the solution and it leaves it that colour. But we're going to put our brass part in there, and we're going to leave that for about 20 minutes, half an hour, and then we'll take it out and have a look. I'm going to show you another material we can use if you can't get sulfuric acid. Okay, this is the best alternative I've found for doing this sort of work, and if you're in a home workshop and you don't want to have acids lying around, especially you've got pets or young children, this is a much safer solution. So we're just going to use ordinary vinegar and table salt. So the recipe is 1 cup of vinegar, that's about 1 cup there, and then 1 tablespoon of salt. And normally what you do is you heat that up to help the salt to dissolve more quickly, but if you leave it overnight, the salt will dissolve into that vinegar quite readily. And the good thing about this is that it works almost as well as the sulfuric acid, but if you splash it on your skin or get it in your eyes, it's not going to be anywhere near as dangerous as the acid. So I'm going to take this upstairs, I'm going to put it in the microwave just to warm it up a bit and dissolve the salt, and then we'll try a piece of brass and a piece of copper in there and just see how well it goes. Okay, that's had about like a minute in the microwave. It's still warm but not boiling. So I'm just going to put a piece of oxidized copper in there. This has just come out of the scrap bin, and we'll put our other corner of our other frame in there. We'll just see how that goes compared to the sulfuric acid. Okay, this has been in the salt and vinegar solution for about 15 minutes, and that solution, by the way, is sodium acetate. And let's have a look at this piece of copper first. So you notice that it's quite pink now. I'll give that a bit of a scrub. This is just water in this bucket here. So you can see there that it's brought that copper up to being that nice bright shiny pink colour. So all of the oxide that was on that surface there is now being consumed by the sodium acetate. Let's have a look at the brass. And you can sort of see from the colour change where it's been sitting in the solution that the oxide is now just turned to this sort of a pink colour. And it cleans up quite readily. But has it removed the flux? Well, it looks like it. There was quite a lot on the inside here. Trouble is, it's a bit hard to get at. But I think you'll agree that that's done a pretty good job. But I'm going to take the one out of the sulfuric acid now, and I'll rinse that next door in the sink, and then we'll bring it back here and compare it. So there it is there. This end here, by the way, I'd cleaned that with a Scotch-Brite wheel, so that's just how it looked before it went into the acid. But again, just a light scrub with that Scotch-Brite pad there, and all of the oxide comes off. And the flux too is now dissolved. So my preference is for the sulfuric acid, but it is more toxic and more dangerous, and the fumes can cause bright surfaces in your workshop to rust. So I keep a lid on that when I'm not using it. I actually keep it outside the workshop. So there you go. Salt and vinegar is a very acceptable alternative to sulfuric acid, and a lot safer, a lot cheaper. And when you finish with it, you can just tip it down the sink. I wouldn't do that with the sulfuric acid though. So pretty good. I'm going to get both these cleaned up now, and then we're going to have a look at making a small part that goes in the bottom of the frame, or bottom and top, and we'll get that one fitted, and I think that's enough for today. There's our two frames sort of partly cleaned up, and what I want to do now is to make two pieces of this 20mm wide brass sheet, and they need to fit in between these edges on the frame. And these are going to be a mounting point for all of the decorative parts that hang off the top and bottom of the light fitting, but also for these light sockets. So this is a ceramic socket with an Edison screw fitting, and it's got a steel right angle fitting there with a couple of threaded holes, and there's our wiring points there. And that's going to allow me to screw those top and bottom from what will be the outside of the light fitting. Now the only problem is that I don't want to solder this sort of like edge to edge. I want it to have more contact areas. So I'm going to machine a slot down both ends of this stock here. This is 2mm thick. The brass angle is 1.6 thick. So I'm going to have to go almost to the back surface, but it can be done. And then I'm going to push that into place and soft solder around 3 edges, and that will give me plenty of contact area. Soft solder will be plenty strong enough for this. Now this is how I'm going to hold this stock here. So I've got this mini pallet in the vise on the mill, and a couple of clamps holding that up against some 8mm dowels. So I can align this square to the pallet, and I'm just going to machine one end square, and then we're going to do that little rebate. It's going to be 2mm wide and 1.6 deep, and then we'll just flip it end for end and do the same at the other end. Well, there it is, and you can see there's not a lot of meat left on that, but it worked okay. And we're just going to machine this to length now and do the same at the other end. Okay, I'm ready to join these little plates onto this brass angle frame that I've made, and there's probably 10 different ways you can do this, but I've decided to do this really old school. So I'm going to use a copper soldering bit on a gas flame. I'm going to be using 60-40 lead tin solder. I've got some zinc chloride flux in a small container here with a silicone brush, and I've got another stainless steel container with some dilute zinc chloride flux. This is going to be used to clean the copper soldering bit before we put it on the metal. So I'm just going to do this one, then I'm going to talk over it as I go and just explain some of the points about using this old school method for soft soldering. The secrets to successful soft soldering are to ensure that you get adequate heat into the work. Now the soldering bit that I'm using today is a 16 ounce, but I don't want to brag or nothing, but I got a really big one. Yeah, that's right, 24 ounces, beat that. I'm using the 16 ounce on this job though, and I'm heating it up at a gas flame, You need to leave it there long enough that the solder is melting onto the tip of the soldering iron easily and quickly. If you have to hold it for a long length of time against the solder, it's not hot enough. If you overheat it, you can burn off the solder coating, or the tinning as we call it, on the end of the bit. So you keep the gas flame low, but make sure that you've got adequate heat. Now you also need to make sure that heat can transfer into the work. Now I've already prepped this material by cleaning it with salt and vinegar or sulfuric acid. I've also scuffed it with a Scotch-Brite pad, and then I'm using an acid flux. Now in this case it's zinc chloride, and it does a really good job of removing any last trace of oxide before you hit it with the heat, and it also forms like an oily film over the surface and prevents oxide from forming as you're heating the material. So oxygen is your enemy when you're soldering. So the other thing is that you need to make sure that you're allowing sufficient contact between the soldering bit and the work. So preferably use the face of the soldering bit or the edge if you can get it in there, and move the soldering bit slowly so that the heat has time to transfer into the work. Now when the temperature of the metal that you're soldering reaches the same temperature as the molten solder on the bit, it will flow like water. It will just flow ahead of the soldering bit, and it will wick into the joints as well. And it should go right through to the back of these surfaces when I'm done. Now if you do all of those things, you will get good clean solder joints with adequate strength. Now you can wipe off the excess solder with a cloth as you go. In my case I didn't do a lot of that. I wanted to build up on the miters so I could clean it back later on and fill the miters. But all in all, these joints turned out really good. They're strong enough for what we're going to do here, and it's simple and easy. So if you haven't tried it before, give it a go. But just one thing, you need to make sure you choose a soldering bit that's the correct size for the work that you're doing. Now one of those little electric soldering irons that you use for electronic soldering is useless on a job like this. It doesn't have sufficient heat reserve, you can't generate the heat quickly enough, and you just simply won't get the solder to run and form an adequate bond. So if you can get one of these old copper soldering bits, buy one. Have a look around junk shops, second-hand shops, often you see them there. But if you can find them and you keep one handy, they are useful for doing this sort of work. Okay, let's finish up here and let's clean it and have a look at it. Okay, well there's one that's just come off the belt sander with that Scotch-Brite belt, and it does a really good job. Puts that lovely satin finish on it. And here's one that I went a bit further with. Now this one has had the edge polished, and I've also fitted one of the light sockets and one of the bulbs, but there'll be a duplicate at the other end later on. Now this is the only surface of this frame that's going to be visible when the light is finished, so I haven't bothered about doing anything with this surface here. I've just sort of sanded that flat. I haven't worried about removing all of the excess solder. This can stay like that. This will be the inside of the light later on, these surfaces here, and with all of the glass tubing in place it'll be diffused enough that you won't see it. So for now that can stay like that. And all the way through this video you've heard me referring to this process I was doing here as soldering. Now my North American friends are probably sitting there and saying, what's he on about? It's soldering. Well, how do you pronounce this word? And how do you pronounce this word? Well, there you go. I rest my case. Now if it's all the same to you, I'm going to head upstairs and I'm going to sit in front of the computer wearing my fireproof panties. I'm going to wait for the comments to come in. And on the next video we're going to do the fabricated parts. So there'll be these sort of caps that go top and bottom, and they're all going to be assembled from strips and plates. And then in the next video after that, if we get that done, we'll do the casting of the decorative elements. So that's all for today. Thanks for watching. It's Prezzo inviting you to come back for the next episode, and I'll see you then. Cheers.